Right, so I'm just going to start this session by doing some reduction angle examples. The first one is tan 339. Just going to use my whiteboard here. So we have tan of 339. Remember, we are trying to see what quadrant that is. So that's 0, 90, 180, 270, 339. So we know that this angle, if we're going to draw it, is that angle there. So the key thing is just first of all knowing what quadrant it's in. So we need to rewrite tan as 360 minus 21. Okay, 21, 39, 49, 59. Okay, so I've rewritten it just so that it's a reduction. I knew it was a 360 minus because it was in quadrant 4. Okay, now I need to look at my three things. First of all, my sign. What is tan in quadrant 4? So based on my cast diagram, tan is negative, so I first do that. Then my function is tan, and then I can reduce 360 minus 21 to 21. If you had to simplify that further, you could simply do that in your calculator. So you would just say negative tan 21. Remember, they've given you the angle, you want the ratio, and the answer to that is negative 0.38 to 2 decimal places. Okay, right. The next one is sine 125. So we write sine 125. What quadrant is it in? 0, 90, 180. So that is 125. So we know that we need to rewrite it as a 180 minus. So that becomes 180 minus, that's 55. Okay. 20, 30. So now we can say what is sine in that quadrant. It's positive. You don't have to write that positive. You can leave it out. My function is sine, and we can drop the 180 and just write it as 55. Another way of just checking this is with your calculator. Try sine 125 on your calculator, and you'll see that gives you 0.819, and then try sine 55, and you see that gives you 0.819. So you can see they're both positive and it's the same size angle, and we're done. Okay, right, moving on to the other side. This is solve using special angles, so they would tell you to do this without your calculator. So I'm going to go and use my board and write 1 over cos 150. So here we have cos 1 over cos 150, okay, and we can leave that alone for now. We want to see where this is, so that's 180, 150, so that's a 150 angle, so we know we're using 180 minus. When you get good at this, you no longer need to use this line, you can just do it automatically, and that is 30, okay, and now we know I can reduce that. In quadrant 2 it's negative, so it's just cos 30. So once you've practiced this enough, you can go straight from this line to this line, and that will be absolutely fine. Okay, now you're using your special triangles. So there's my 30-degree angle, and that is going to be 1, 2 root 3. So I can just put the negative on the side, it doesn't matter. And that is 1 over, and then cos 30 is root 3 over 2. And then you know that you can simply flip that over, so it's negative 2 over root 3. Okay. And yep, those are just a couple of examples of those. This one here, just before I give you the answer, you can try it on your own. I'm going to just pause. Let me just quickly erase my board. You can try that other one on your own so long, that one there. I was doing this for a living, it would probably be a bit unprofessional of me to be using my handy cloth and wiping my board, but we are in a classroom and these are things that we have to do. Right, so I'm going to write this one down here. 3 cos squared 150 over cos 180 over tan 315 minus cos squared 240. Okay, so these questions here, I'm just going to zoom this out a little bit so that fits on nicely. These sums here are usually worth quite a lot of marks, and they're not difficult marks. So the first thing I need is just a cast diagram. And this time here, I'm not going to put that middle line. I'm just going to go right ahead and do all my reductions. So I put my 3, and then it's not a bad idea just to use brackets so that you don't get confused between subtraction and multiplying by negative. Okay, so first of all, I have cos squared 150. 150 is in this quadrant here, so it's a negative cos, and 150 is 180 minus 30. Now, just an important thing with that squared, because you get a mark for getting your signs right, it's not a bad idea because it's cos squared to write it like that. Because when I square the negative, it's going to be positive. But here they sort of know that I knew that cos was negative in that quadrant. Okay, and then cos 180, we are simply going to just either use our calculator or then just think of it in terms of the curly cap cos, and that's 0 to 9180, so we know it's going to be at -1. So that's just multiplied by -1. Okay. And then tan 315, that's going to put it into that quadrant, so it is going to be 360 minus 45. So we can just say, first of all, tan is negative, my function is tan, and then it's of 45, and I put that into brackets. Okay, then remember there's a negative sign over there, and then it becomes cos squared 240. Now 240 is in this quadrant here where cos is negative, so I'm putting my negative, my cos, and 240 is 180 plus 60, so I can just go right ahead and reduce that to 60. Okay, now the rest is just a matter of using your special triangles, and that I think from here on you can do no problem. Just remember when you square it that you need to square your negative as well, and the rest I'm going to leave so that this video doesn't get too long. Okay, right, what I want to go on and do now is have a look at this, by the way, is just a summary. It's just showing everything that happens in this quadrant is 180 minus theta, and then also 90 plus, which we're going to get to now. Okay, this one is theta, 360 plus theta, and then 90 minus theta. And this is 180 plus, this is 360 minus, or just negative theta. So it's just really a summary of what's happening in each quadrant. Okay, right, negative angles. All we are doing here in this part of it here is when we have theta, it's going in a positive direction. When we have negative theta, it is going in a negative direction. That means it's going clockwise. Okay, so all this is saying when they have negative sine negative theta is that, let's say it was a 30-degree angle. Instead of going 30 degrees in that direction, we're now going 30 degrees in that direction. Okay, again, if I can go back to my diagram that just had the graphs on it, it also helps just to see what it is in terms of symmetry. So with my sine diagram, if I had 30 degrees, which would be about there, and I had minus 30, you can see for sine that the height there and the height there is probably about the same, but it's now, when it's negative 30, it's got the opposite sign. Instead of being positive, it's negative. Whereas cos is symmetrical, so if I had to go to 30 degrees there, and I had to go to negative 30, they are both positive. Okay, tan, you can see if I go to naught, let's use 45 because it's nice and simple and it's already indicated. If I had a positive 45 and a negative 45, just in terms of symmetry on that axis, the positive theta has the opposite sign to the negative theta. And hence, just in terms of what this is saying, is that sine negative theta is the same as negative sine theta, cos negative theta, cos theta, and tan negative theta, negative tan theta. The easiest thing with the cofunctions, with the negative angles, is just to really look at it in terms of the Cartesian plane. Negative theta is in this quad, and because it's over there, and all we need to say is what is sine in quadrant 4, it is negative. What is cos in quadrant 4, it is positive. What is tan in quadrant 4, it is negative. And we've worked out our negative angles. The only problem is sometimes we have angles that aren't just between 0 and 90 degrees. Sometimes we have ones that are like sine 240. Okay, so I'm just going to write that on my board here. So if I have, for example, sine negative 240, just to get a visual picture of what we're doing here, remember we're starting at 0, we're going minus 90, minus 180, minus 240. Okay, so theoretically, that's what it looks like. Okay, the important thing to remember is that you know that whatever you're reducing to, you know you're going to get a positive sign, because according to my cast diagram, in this quadrant here, sine is positive. So you know it's going to be positive. Now, you can try and figure it out in terms of if that's 180, I'm going another 60 in this direction. So this angle here will be 60. So you can do it intuitively, that's fine. If you want a foolproof method, this is the other way that we do it, is remember if I take an angle and I add 360 to it, remember it's going in a clockwise direction, all I'm doing is I'm winding it back a full revolution. It doesn't change the size of the angle. I can do it in a positive direction, a negative direction. I can go 360 as many times as I like. But 360 is quite a useful number because it keeps the angle the same. So theoretically what I can do is just say I've added 360 to the minus 240. Okay. And that basically leaves you at sine 360 minus that, that's 120. And now it's back to what I'm familiar with. Okay, sine 120 is just sine. Remember, this line is not important. That's 180 minus 60. And then we're back to where we are. This quadrant here means that it's a positive. My function is sine, and I can reduce it to 60. And then just use my special angles to solve it. Okay, so there's two ways we can do it. We can do it intuitively and just look at what we're actually doing if the angle is bigger than just a simple 90, or we can just bomb on a 360 to whatever it is. It will then make it a positive angle, and then it's back to reduction formula as usual using our cast diagram. Okay, so don't be intimidated by negative angles. They're all just part of reductions, and all we are doing is we are simply going to add 360 to it. Or if you have a look at this one here, it is minus 390, so we can actually clock it round twice if we want to. Okay, so I'm going to stop there. That's the end of negative angles.